Welcome to section 2.3. We are working today with long division and synthetic division. To start, I'm going to go back through the basic idea of long division with numbers so that we can end up getting with polynomials. So we're going to start by dividing 943 by 6. And let's go back to the ideas that we did in 4th grade. So we're going to ask ourselves, does 6 go into 9? We say yes, it goes in once. And 1 times 6 is 6, so we end up subtracting 6. 9 minus 6 is 3, and we drop down the next number. So we ask ourselves again, can 6 go into 34? The answer is yes, 5 times, because 5 times 6 is 30, so we subtract 30 and get 4, and drop one more number down. We bring the 3 and we ask ourselves one more time, can 6 go into 43? The answer, yes, is 7. And so 7 times 6 is 42. When I subtract, I'm running out of room, but I do have 1 as my remainder. Now, in elementary school, they let you say a remainder of 1. We don't. Okay, so please do not put that. I'm going to show you actually how the answer is written. It should be 157, and we have 1 out of the 6 remaining. So this should be our answer, 157 and 1/6. But I do want to get you some vocab words along the way. The dividend is the number that goes under the division sign, so 943. The divisor is what we divide by, which in this case is 6. The quotient is the whole number that's left, so our quotient is 157, and our remainder is whatever number is left. In this case, it's 1. And so this is the idea when you talk about basic long division. We're going to try a polynomial as well. So we're going to set it up the same way. We're going to say we take 6x cubed minus 16x squared plus 17x minus 4, and we're going to divide that by 3x minus 2. Okay? And then we're going to end up, we can fill out actually a couple of these so far. The dividend, 6x cubed minus 16x squared plus 17x minus 4. And our divisor is what we divide by, so in this case 3x minus 2. And our goal is to end up finding what is the quotient and what is the remainder. Okay, so as we go through, the way this works, you're looking at this outside number first. And you basically say 3x times what gets you 6x cubed. Well, 3 times 2 will get me 6, and x times x squared will get me x cubed. So I take this 2x squared and I multiply it now by both of these numbers. So 6x cubed when I take 2x squared times 3x, and 2x squared times negative 2 is negative 4x squared. And once I figured out what I did, like I did above, I'd subtract my number. So I'm going to subtract the whole quantity. You should find that the x cubes then cancel out. And then negative 16 minus negative 4 is the same thing as plus 4, so you get negative 12x squared. Okay, now I'm going to change my number, or my color a second, so that you can see the next step as we go through. So you say 3x times what is negative 12x? Well, 3 times negative 4 makes negative 12. And x times another x will get me the x squared. And then I take this number, let's actually do something first. We drop the 17x down, I apologize. So now I take negative 4x times both of these, so negative 12x squared. And negative 4x times negative 2 is a positive 8x, and I subtract. Well, when I subtract these, my x squared should cancel. That was the goal. I forced them to do that. And 17 minus 8 then is 9x. And again, I'm going to drop down my next number of negative 4. And then I'm going to switch colors one more time so that you can see the last step. I asked myself one more time, 3x times what gets me 9x? Well, 3 times a positive 3 will get me 9. And I already have the x, so I don't need a number. So 3 times 3x is 9x, and 3 times negative 2 is negative 6, and then I subtract my whole quantity. The 9x's cancel. Negative 4 minus a negative or plus a 6 makes 2. Oh, I'm sorry, I'm sorry, that's why it took so long. This should be a plus 4. So let me erase this a second. I apologize for that one. This is a positive 4, so positive 4 plus 6 makes 10. Wondering why my number is not looking right. So take a look. Our quotient is what's on top. So our quotient is 2x squared minus 4x plus 3. Our remainder is 10. And if we don't specifically ask you for these separate, then here's the answer we're looking for. If we just ask you for what's the answer, it should be 2x squared minus 4x plus 3. And like we did above, you know, we took the number, our remainder divided by our divisor. We're going to do the same thing. It's a positive 10, so I'm going to say plus 10 over, and we divided by 3x minus 2, so over 3x minus 2. And this would be our final answer if we did not ask you to separate this quotient and remainder. Okay? And so we're going to try a couple more of these just so we get used to looking at this. I'm going to change my color again, get back to a better color. And then let's go through a couple more. Of this. Okay, the division algorithm is something that your book describes, and all I want to do is give you the notation so that you're used to seeing it. If f and d are polynomials such that d can't be 0, degree is less than or equal to degree of f, then there's polynomials of q and r. And so basically, here's what it says. I can give you a function f of x, where a polynomial d times a polynomial q plus a polynomial r would end up equaling this f. And let me put it in terms of words of what we've already done. F is our dividend, okay? So it's our long polynomial that we divided our divisor by. And so when we divided the divisor out, we got a quotient and a remainder. And so what it basically says is if I went back to double check, I could take the divisor times the quotient, and once I was done, add the remainder in. I should end with this dividend. If I don't, then I did something wrong in my long division. And that's all this division algorithm is saying. So let's try one more. Divide x cubed minus 1 by x minus 1. And I love this question, truthfully, because I'm missing pieces. Okay, and you'll notice I have an x cubed, but I don't have anything else until I get to a 1. And so I'm going to put this over here so I have a little bit of room. But what we need to do is put in placeholders then for the squared and the x term, and then I have a minus 1. And I'm going to divide that then by x minus 1. And so if you are missing pieces, you have to put these zeros in to account for the fact that you're missing pieces. Okay, so here we go. We start with the outside one. X times what is x cubed? We end up getting an x squared. And I don't care where your numbers go on top. If you want to line it up with the x squareds, you can do that. So I take the x squared times both of these. I get x cubed minus an x squared, and I then subtract. The x cubes will cancel. 0 minus a negative 1 just means plus 1, so I end with x squared, and I drop down the 0x. Let's change color. Actually, let's go. And then I do my next step. X times what makes x squared? You get one more x. So x times x is x squared. X times -1 is -x. And I again subtract. My x squared should cancel. 0 minus a -1 means +1, so I'm left with an x. And I drop down my 1. Let me go one more color here. Okay, x times what makes an x? That's times 1. So 1 times x is an x. 1 times -1 is -1. And when I subtract, nothing remains. So I have 0. I don't have a remainder. You don't need to include that in your polynomial. My answer then is x squared plus x plus 1. Okay? I'm going to go through one more with you and then we'll talk about synthetic division. So we're going to take this, pause this one and try on your own. And then what I'm going to do is I will put up my work then and you can double check. Okay? All right, thanks for coming back. I'm looking at the fact that you tried this last one on your own. Let's see how you did. So we're going to do x plus 2, and we're going to divide that by 3x cubed plus 8x squared plus 5x and a -7. Okay, x times 3x squared makes 3x cubed. So 3x squared times x is 3x cubed. 3x squared times 2 is 6x squared. And when I subtract, these cancel. I get 2x squared, and I drop down my 5x. X times 2x gets me 2x squared. So 2x squared and 2x times 2 is a positive 4x. So I subtract and get an x, drop down my -7. X times 1 gets me this x that's here. So I'm left with an x plus 2 when I take that 1 times x and 1 times 2. And I subtract. -7 minus 2 is -9. So your quotient is 3x squared plus 2x plus 1. Your remainder is -9. However, your answer, we want to combine those together. 3x squared plus 2x plus 1. And it's a -9, so I'm going to say minus 9 over my divisor, which is x plus 2. Here's your final answer. Okay, I hope through the 3 examples that we've done that long division got a little nicer for you. I'm going to show you the shortcut, but please make sure you can do this long division. That is one of the things we're going to ask you to do on the quiz and the test. So let's slide down. We're going to do synthetic, and I'm going to do the same example that we did above for the synthetic. Okay, and so what I'm going to do basically is instead of doing the bar, the normal division bar, I'm going to do kind of an upside down division bar and a little bit bigger. Okay, the number that goes in front, our original divisor was x plus 2. We're going to set that equal to 0, and we're going to find what the 0 is, because this is the number that's going to go in front. Okay, and then the only thing that goes in the box are the coefficients of my dividend. So the coefficients were 3, and then a positive 8, and a positive 5, and a -7. And the reason I'm doing the same one is I want to show you how it relates to the long division above. The process goes like this. Drop the first number below the box. Once it goes below the box, you multiply the number outside of the box with the 0. So 3 times negative 2 is negative 6, and the negative 6 goes in the box. 8 minus 6 is 2. And you do it again. 2 times negative 2 is negative 4. 5 and a negative 4 makes 1. One more time. 1 times negative 2 is negative 2. Negative 7 plus negative 2 is negative 9. And what you'll notice is these are the same numbers that are left in the answer we had above. And the way it works, the last number is always your remainder. Then you're left with your number, your x, and your x squared. If I had more numbers, it would go x cubed, x to the 4th, and so on and so forth. And so we're going to write this back as a polynomial. 3x squared plus 2x plus 1 minus a 9. Now here's the problem. You have to go back to your original polynomial. So an x plus 2 goes on the bottom. Okay, now I do want to change colors a second because I want to point out a few things. If you look at yours above, this is what happened when we subtracted our x's. And this is what, our x squareds, I'm sorry, this is what happened when we subtracted our x's. And this is what happened when we dealt with our numbers. And so it really does the same thing as the long division. It just excludes all of the x's, which tend to be a little messy. The biggest thing, though, is if your dividend is x minus k, what you end up getting at the end, the remainder is f of k. If I were to plug in f of, they're asking you basically f of negative 2. If I did my original f of negative 2, so I would take 3 times negative 2 cubed plus 8 times negative 2 squared plus 5 times negative 2 minus 7. Guess what, guys? I get negative 9. And so the synthetic division, when you're actually trying to evaluate a function, we call it synthetic substitution, but basically it's the same thing, and your Algebra 2 book called it the synthetic substitution. This synthetic substitution basically says you can use the synthetic division to find f at negative 2 if you wanted. It's just your remainder, which is sometimes easier than dealing with all of these exponents. And so that's an option as we go through. There's also this thing called a factor theorem. And basically what it says is if I have this factor, I only know it's a factor if f of k equals 0. Or basically what it's saying is I have no remainder. If I don't have a remainder, then I know that this would be a factor. And an example of that would be the one on the first page where we said divide x cubed minus 1 by x minus 1. We ended up getting no remainder, and so that kind of told us that this x minus 1 is actually a factor of this polynomial. So that's kind of another nice little thing. We're going to do one more example as to why synthetic is the better method when you're working with more advanced problems and it's less time consuming. This is an Algebra 2 example, but this for sure will be on your quiz. Okay, so plan on this. What we're going to do is we're going to give you 2 solutions, and another word for solutions are 2 zeros. And so if we give you these 2 zeros, the easiest way to find the remaining zeros is synthetic division. So pick one of these zeros. I'm going to go in order, and I'm going to do 2, and I'm going to synthetic divide. So 2x to the 4th, I don't need the x, 7x cubed, negative 4x squared, negative 27x, and a negative 18, and I'll extend my line. And what we're going to do is some synthetic division. Okay, so here we go. First step, drop the 2 down. 2 times 2 is 4. 7 plus 4 makes 11. 11 times 2 is 22. Plus a negative 4 is 18. 18 times 2 is 36. Plus a negative 27 is 9. And 9 times 2 is 18. I get a remainder of 0, which should happen if they tell me it's a 0. I should end with 0 if they tell me it's a 0 or a solution. Okay? What we're going to do is use the other one with these remaining coefficients. So I'm going to take this negative 3 now, and I'm going to do one more synthetic. I just don't need this remainder anymore. So I'm going to drop the 2 down. 2 times negative 3 is negative 6. When you add that to 11, you get 5. 5 times negative 3 is negative 15. When you add that to 18, you get 3. 3 times negative 3 is negative 9. When I add it to 9, I get 0. This better happen if they tell me this is a 0. So we've worked our way down, and if this was my remainder, here's my number, here's my x squared. So I'm left with this polynomial of 2x squared plus 5x plus 3. And my goal is to find the other zeros. So I'm going to set this equal to 0. The best way to do it is to factor. You can use the snip method, you can use guess and check. I'm not going to go through that, but if you need help, let me know. What I am going to do is give you the factors, 2x plus 3 and x plus 1. And according to the factor theorem, I set both of these equal to 0. And I can get my other zeros. So I have here x is negative 1. That's 1, 0. I also, when I solve this, get that x is negative 3 halves. There's a second 0. Plus I have a third 0 of x equals 2 and a fourth 0 of x equals negative 3. And we talked in previous sections that this degree here of 4 tells us we should have 4 solutions, and we do. 1, 2, 3, and 4 solutions. And so please make sure that you look at the degree first to figure out how many answers you'll have. Please take a look. I'm not sure if this is the correct problems. Please take a look at the schedule that you have, because that one is correct and I modified this at times. So please take a look. If you have questions, circle and star along the way, and please let me know. Thank you for watching, and have a wonderful evening.